We are discussing about AC three-phase system. Now, concept of electrical power generation. As we know, there are two types of supply generally we are having at our home. One it is single phase AC and three phase AC. In case of single phase AC, we are having one conductor as phase and another as neutral. Whereas in case of three phase, we are having three different conductors are labeled as R, Y and B. R, Y and B. Here in case of single phase, we are having phase and neutral. Neutral and phase. Now, in between this single phase and three phase system, there is a two phase as well. In case of single phase system, only one conductor is placed in the magnetic field, then there will be a development of EMF. If current is leaving from this end, then it will be entering from this end, and hence we can say there are two conductors, and if load is connected over here, then current will flow in this direction depending upon the magnitude of rate of change of flux linkage. Now we can say the current, there is a two conductors, and in between load is connected. Whereas in case of two phase, we are having two different conductors and they are displaced by an angle of 90 degree, and hence the phase displacement of two phase supply is 90 degree. Now, in case of three-phase system, we are having three conductor R, Y, and B. These are the return path of R, R dash, return path of B is B dash, and return path of Y is Y dash. Now, in this case, the conductor, since we are having only one conductor, there is no concept of phase lead or lag or sequence. In this case, we are having two conductor. It means phase sequence will be having either 1 to 2 or 1 to 2 or 2 to 2 to 1. Now, in this case, since we are having a three conductor, the phase sequence may be RYB, it may be RBY, or it may be RBRY, depending upon the placement of these three conductors. Now, considering single phase, in case of single phase, we are having a waveform for the circuit, that is either it is current waveform or it is voltage waveform. Whereas in two phases, we are having a two different waveform for R phase and Y phase. Here we consider only a R phase. Now, in case of three phase supply, we are having three different phase R, Y and B. This is the representation of single phase quantity with respect to reference. Since there is only one quantity, there is no meaning of phase differences. In this case, we are having two different quantity, one quantity and another quantity are displaced by an angle of 90 degree, and hence if ER is the phase voltage R, then EY is the phase voltage Y, and the angle between these two quantities is 90 degree. Whereas in three phase system, since we know the peripheral angle is 360 degree, and hence three conductors are placed at a 120 degree apart from each other. If this sequence is always referred in a clockwise direction. If R, Y and B, if R conductor is taken as reference and Y conductor is after this R conductor and B conductor is further after 120 degree from Y conductor, then phase sequence will become R, Y, B. Instead of having B conductor over here, if we are having instead of having Y conductor, if we are having B and here will be Y, then the sequence will become R, B, Y, and so on. The sequence of the conductor can be changed with reference to these three phases R, Y, and B. And this is the waveform for R phase. After 120 degree, the second phase will start, that is Y phase, and after from here 120 degree, the third phase will start from here. This is the third phase, B phase, and then it is drawn in reverse direction, taking the different instant. It will be maximum at 90 degree, it will be maximum at 210 degree, and it will be maximum at 330 degree. Now, three phase displacement in case of single phase supply has no meaning. Phase displacement in case of single phase supply has no meaning since there is only one conductor. EMF developed in two phase supply always has a 90-degree phase displacement. In three-phase supply system, phases are 120-degree displaced from each other. In three-phase supply system, phases are represented in sequence of R, Y, B with color coding as R is red, Y is yellow, and B is blue. The sequence depends upon the placement of conductor in a magnetic field. The neutral conductor has black color coding, whereas the green conductor generally is used for earth wire. Now, advantage of three-phase system. Though we are having single-phase and two-phase system, but generally all over the world we are generating power using three-phase system. Because of there are certain advantages. The number of conductor required in three-phase system are for same power transmission is less as compared to the other supply system. If we are having a three single-phase sub system single phase system, then we do require one conductor, two conductor from each phase. And if we are having a two phase supply, then we are requiring four conductors, one conductor from each phase, two conductor from each phase. Whereas if we are having a three phase supply, then we can transfer power by having three phases instead of having a six conductors. And these three phases can be connected either in star or in delta, and then accordingly power can be transferred. The power rating of three phase machine of same size is higher than single phase machines. If we are having three different machine of single phase, then we can do the same work by having one single machine of three phase. Three-phase electrical motors are self-starting, whereas single-phase motors are requiring some external mean to start. For example, capacitor used in fans. At our home, we are having a fan, and this always there is a capacitor in the fan. If we remove that capacitor, the fan will not start. Okay, energy efficiency. The system, if we are having a three independent system to convert the electrical energy into useful output instead of a single three phase system, that will be consuming more power because of more losses will occur, whereas a single consolidated system to do the same work will be consuming less power and hence delivering output at higher efficiency. Now, in case of three-phase supply representation, let me consider the voltage in first phase is Vm sin omega t. Since the second phase is displaced by an 120 degree, then the voltage in the second phase is Vm sin omega t minus 120 degree. The voltage in third phase is displaced by 240 degree as respect to Vr and 120 degree from Vy. Then we can say Vm sin omega t minus 240, or simply it can be written as Vm sin omega t plus 120. Here it is Vr, here it is Vy, here it is Vb. This is by less than minus 120, whereas this is plus 120. This is minus 120 behind this, and this is anti-clockwise, and hence it is taken as plus 120 in respect to Vr. Similarly, if there are three phases, then correspondingly there are three different current. IR is equal to Im sin omega t plus minus theta. Plus minus here means your load can be RL and your load can be RC or RLC, depending upon the dominancy of L or C. In case of RL circuit, the circuit can be RL, circuit can be behave like a RC. Whereas in RL circuit, the theta will be plus, whereas in RC circuit, the theta will be minus in case of current. Now, in case of RL circuit, the theta will be minus, whereas in case of RC circuit, theta will be plus, because in RL circuit current will lag the voltage by an angle of theta. In case of RC circuit, current will leads the voltage by an angle of theta. Considering in generalized case, that is plus minus, then if we apply at any instant the sum of all the voltage in a circuit, then Vr plus Vy plus Vb, then putting the value of Vr, Vm sin omega t, Vy, Vm sin omega t minus 120 degree, Vm sin omega t minus 240 degree. Solving this trigonometrical function, the resultant value will be 0. Similarly, if we can add all these three current at one point, the resultant value of current will be 0. Now, phase sequence. There are some terms associated with the three-phase supply. One is the phase sequence, and another it is the balanced or unbalanced system. Phase sequence, here it means an order or sequence in which current or voltage in different phases attains maximum value one after the others. That is, This is the maximum value of R phase, this is the maximum value of Y phase, this is the maximum value of B phase. Because after R phase, Y phase attains the maximum value, after Y phase, the B phase attains the maximum value, and hence the sequence of this particular connection is R, Y and B. Now, the sequence, the shows the sequence of, let's consider this is the figure, this is R, this is Y, this is B. The sequence is R, Y, B. Whereas if we are considering this is R, this is B, this is Y, this is R, this is B, this is Y, voltage, this is voltage function, then sequence will become R, B, Y. This is the figure shows the sequence of R, Y, B, whereas if any two terminals are interchanged, the sequence will be get changed. For example, RYB and BRY. Balanced or unbalanced system. In a three-phase system, since we are having three different individual loads and three different phases, then it can be considered as a balanced system or unbalanced system. In case of balanced system, if Z1 theta 1 equal to Z2 theta 2 equal to Z3 theta 3, that system is known as balanced system. However, if in any case Z1 theta 1 is not equal to Z2 theta 2 but it is equal to Z3 theta 3, it is considered as unbalanced system. Similarly, if Z1 theta 2 is equal to Z2 theta 2 but it is not equal to Z3 theta 3, then also this system is considered as unbalanced system. For balanced system, in other words, we can say Z1 must equal to Z2 must equal to Z3 and theta 1 must equal to theta 2 equals to theta 3. Otherwise, if any of one condition is violated, then system is considered as unbalanced system.